Hey everybody, welcome back to the ECG of the day. My name is Reid. I'm excited to go over this ECG here with you all. Don't forget to download the PDF so you get your own copy of this ECG in the description below. And go ahead and like and subscribe if you enjoy these videos. So let's go and jump into it. So the first thing I'm going to do is look at the forest, and the trees of the forest are my QRS complexes. So let's take a look, maybe starting here in V5. I notice I've got a narrow complex tachycardia that is regular. There are no pauses throughout the rhythm. There's no real changes in the rates in the R-to-R intervals, and it's a narrow complex rhythm. If I look at how fast this rhythm is, what the rate is, I can find a QRS that ends right here on the solid line, and I can count here 300, 150, just teeny tiny slower than 150 beats per minute. I would say maybe that's 145 beats per minute. So I've got a regular narrow complex tachycardia at 145 beats per minute. So because it's a narrow complex tachycardia, I know that this conduction through the ventricles has to be coming from at least the AV node and higher. So this is a rhythm that is coming from at or above the AV node. So this is above the ventricles. And so a couple causes that we can think of. We can think of is this an SVT, such as an AVRT or AVNRT. Is this a fib? Is this a flutter? Is this sinus tachycardia? And so, or is this an atrial tachycardia, like an ectopic atrial tachycardia? And so there's a couple things we can do to kind of work our way through this. And so first thing we're going to do is evaluate the atrial activity. So we see, we're looking for discrete P waves that can help us determine if it's a sinus tachycardia, if it's an ectopic atrial tachycardia. And I don't see, I see some deflections for sure. If I look at lead 2, I see some deflections here. These little humps look like some atrial activity. I look over here in AVR or V1, I might see the same thing. Some of these little deflections that might help determine that there is some atrial activity going on. The best thing I look for here is I can see in lead 2 and lead 3, I got some really good clues to tell me about what's going on. So if you notice here, if I zoom in on my QRSs here in lead 3, what you'll notice here is that I've got this narrow deflection up, narrow down, and then I've got what appears to be a little kind of an odd slurry deflection that's occurring at the end of all these QRSs. And we know that narrow complex QRSs are usually sharp, but this kind of has this upward deflection that is a little bit slurred. I can see that here in lead 2 as well, where you've got this notching at the end. That's not characteristic of an ST or T wave. Something else I want you to remember is that T waves are very slurred. P's or atrial activity is more spiked. And so when I look at this, what appears to be a T wave, notice that it's spiky. Those are very sharp deflections. We can say sharp deflections that are not entirely characteristic of ventricular repolarization. That is our T waves that we would expect to be there. And so what do I really see? I see a baseline atrial activity. You have to kind of see through the rhythm here, but I see a sharp deflection there, and I see a sharp deflection there. These sharp deflections really remind me of P or atrial activity. And if you put them all together, you get this sawtooth pattern that is running through this ECG. And that sawtooth pattern, the rate of the sawtooth is essentially, that rate between each other is about 300 beats per minute. And so what is going on here? If my ventricular rate is around half of that, this makes me think I've got atrial flutter, right? Because the atrial flutter usually is an atrial rate of anywhere from 250 to 300 beats per minute. And if my ventricular rate is half of that, I would say with 2 2-to-1 conduction. And what that means is that if I'm having this flutter, usually the atrial flutter occurs around the tricuspid annulus, right around here. And what happens is you get a flutter wave, you get this reentry circuit. It goes around and around, and every 2 times it comes around, it activates this AV node and it sends it down to the ventricles. You get a narrow QRS. Then you go around once, around twice, sends it down again to the QRS. And that's exactly what we're seeing here with this atrial flutter with 2-to-1 conduction. One thing you can always think about is anytime you have a narrow complex tachycardia with a rate that is roughly 150 beats per minute, think atrial flutter with 2-to-1 conduction. Okay, so we've kind of sussed that out a little bit. Well, what else can we do? We can evaluate our QRS because our QRS complex typically is independent of this tachycardia. So what I notice is I've got a QRS that is isoelectric in lead 1, and it is positive in AVF in my inferior leads. So that means that my QRS axis is roughly down towards AVF. It's a normal axis. I've got no evidence of any type of right ventricular hypertrophy or left ventricular hypertrophy here. And so now we can look at our QT intervals. Got to find a lead that gives you a nice view of our QRS and our T waves. I think V5 down here at the bottom looks good. And it appears that this T wave ends roughly halfway between our R to R intervals. Maybe not perfect, but I say I'm happy with this QT because we're looking for that T wave to end the midway point between the R to R intervals. Last thing we're going to do is we're going to evaluate our QRS for any pathological Q waves, which will tell us if there was any previous myocardial infarctions in the region. I don't see any. I also don't see any ST or T wave changes, right? Because atrial flutter, we need to evaluate for any type of ischemic changes that could have triggered the heart to go into this arrhythmia. I don't see any. And so ultimately, what is our final diagnosis? We've got a atrial flutter with 2-to-1 conduction at a rate of 145 beats per minute. So big takeaways here, right? We made this initial kind of differential diagnosis here on the left side. First thing we're going to think about is, how can we differentiate between these? Atrial tachycardia, you might see an ectopic P wave. Sinus tachycardia, you'll see a sinus P wave. You also know that the sinus node can only beat so fast. In AFib, you're going to have an irregular rhythm. Atrial flutter, you could have variable conduction, or you could have fixed conduction like we have here with 2-to-1. And lastly, SVT, such as AVRT and AVNRT. If you have AVRT, you might have a history, say, of both Parkinson-White, and you can have like a long RP tachycardia. An AVNRT, you're going to see maybe pseudo R waves in V1. It's kind of an advanced concept, but there's little ways you can kind of work through all these different tachycardias. But it's important to have a framework and develop a differential diagnosis early on when you're in your evaluation of the rhythm. So if you have any questions, put them in the comments. If not, hope this helps, and we'll see you tomorrow. Don't forget to subscribe to the channel. Thanks for watching.